This is a quick lesson on the concept of acceleration. Acceleration is one of those things that has a very simple definition, and yet it's really easy to get it mixed up with other things. This is a huge problem for students when they're first learning physics. I see a lot of students confusing acceleration and velocity, or even acceleration and force, acceleration and other things. Acceleration is a change in velocity. So when we're talking about accelerations, if acceleration is 0, then objects should have no change in their velocity. If the acceleration has some value that's not 0, then the velocity of the object should be changing. But let's take a look at the sneaky ways that velocity can change. So for most American students, the clearest example of acceleration is a car speeding up. So imagine you're in a car stopped at a red light, because you're supposed to be stopped if the light's red, and then the light turns green and you start going. In fact, what's the name of the pedal that you're pressing in your car? It's called the accelerator. So we know that we're going to experience acceleration. If I draw a particle motion diagram, which just like my handwriting on the screen is a little bit untidy, I begin at rest, the light turns green, and I start to go. If I'm speeding up, which is a form of acceleration, then my dots should be getting farther and farther apart. This increasing distance between the dots tells me that I am accelerating. My velocity is changing because my speed is becoming greater. Here's a different scenario. This time, the car is in motion when the driver sees a red light. Better stop for a red light. The car comes to a stop. In this case, if you're driving, which pedal do you press? We call it the brake. But do you know what? It's an accelerator too. It just accelerates by changing the velocity in a way that the speed decreases. The car slows down. Is that a change in velocity? Yeah, then that's definitely an acceleration. Sometimes the terminology used is deceleration, but using the word acceleration is also perfectly acceptable and accurate for describing an object which is slowing down. So far, we've had two examples of changing velocity. Speeding up was the first one. Slowing down was our second one. Both are acceleration. Let's stick with our car theme, since many of us drive cars, possibly every single day. And let's think about going around a corner. So you might take a corner at constant speed. You know, if it's a comfortable corner, you don't even have to slow down. You go around. Let's pretend these dots have equal spacing between them. I am going to tell you that your velocity is changing. And you're going to think, no, it's not. You said constant speed. But it is. Velocity is changing because velocity is not the same thing as speed. Velocity includes information about the direction. And let's take a look at what that means. Even though you may be traveling here at a constant speed, your direction of motion is changing, which means that your velocity is changing. And if velocity is changing, then you must be accelerating. So even though you're not touching the accelerator or the brake, which is also a type of accelerator, by turning your car, by turning the steering wheel, you are also accelerating. So we have three options for changing velocity. An object can speed up, it can slow down, or it can change direction, or it can do some combination of those things. When you really drive your car, you might slow down going into a corner, so slow down and turn at the same time, and then coming out of the corner, you might speed up. You might speed up and turn the corner at the end. And so you're doing really fancy compound types of acceleration. The takeaway message here is that don't get tricked by thinking that acceleration means speeding up. It doesn't. Acceleration is any change in velocity, and there are three options for this. We can speed up, we can slow down, we can change direction, or some combination of those. So scientists have a reputation for being kind of dry and not being really fun to be around, and part of it isn't really their fault. The thing with science is that we have to use language and vocabulary so specifically. We have to constantly monitor what we're saying and just be careful, careful, careful. This is the case with the word acceleration. Acceleration is easily confused with other things, and if you confuse it, you'll make mistakes. So, acceleration can be a change in speed, or a change in direction, or a change in both speed and direction. When you're reading a physics problem and it mentions acceleration, stop and think, what exactly does it mean? Is it only the speed that's changing? Maybe the speed's constant and it's only direction that's changing. Or maybe both speed and direction are changing. You need to figure that out when you see the word acceleration. When you use the word acceleration, when you talk about physics or when you write about physics, make sure you're using it accurately. You should only use the word acceleration if speed is changing or direction is changing or both speed and direction are changing. Acceleration has a very, very specific definition. Also keep in mind that terminology like speeding up, slowing down, decelerating are not as precise as acceleration. Those are kind of special cases. Acceleration covers any time when speed, direction, or speed and direction are changing. And that concludes this lesson on acceleration.